On May 16, 1940, William Cudson sat in his office at General Motors headquarters in Detroit, reading a telegram from Washington. The message stunned him. President Roosevelt had just addressed Congress with a proposal that seemed impossible. America needed the capacity to produce 50,000 military aircraft per year. Cudson was not some factory supervisor. He was the president of General Motors Corporation, the largest manufacturing company on Earth. He commanded over 200 plants and 350,000 employees. His annual salary exceeded $300,000, more than any other corporate executive in America. He had spent 37 years building his reputation in manufacturing. He knew cars, he knew factories, he knew production lines. He understood what Roosevelt was really asking. The president wanted American industry to gear up for war production on a scale never attempted before. In 1939, the entire United States had built fewer than 3,000 military aircraft. The nation had 1,700 planes total in the Army Air Corps. Most of them were obsolete. Now, Roosevelt was calling for production capacity of 50,000 planes annually. That was more aircraft than had been built in America since the Wright brothers flew at Kitty Hawk in 1903. The implications were staggering. If America actually needed that many aircraft, war was coming. And when it came, Cudson knew his world would change completely. Within 2 weeks, Roosevelt would ask him personally to leave General Motors and come to Washington to organize America's industrial mobilization. Cudson would accept. It was May of 1940. France was collapsing. Belgium had fallen. The Netherlands was gone. Hitler's armies were pushing toward Paris and the English Channel. Britain stood alone, and Roosevelt was asking American industry to build an air force larger than anything the world had ever seen. The problem was nobody believed it could be done, especially not the Germans. In Berlin, Adolf Hitler received Roosevelt's speech with what his advisors called amused contempt. The Führer's intelligence officers prepared a report on American industrial capacity. Their assessment was clear. America could not build 50,000 aircraft per year. The claim was propaganda designed to intimidate Germany and boost Allied morale. The intelligence analysis was logical. American aircraft production in 1939 totaled fewer than 3,000 planes. Even with maximum effort, German analysts estimated America might reach 10,000 aircraft annually by 1942. 50,000 planes was fantasy. The German Air Ministry had detailed information on American factories. They knew Boeing, Douglas, Lockheed, and Consolidated. They knew these companies built aircraft one at a time using hand-fitting methods. Skilled craftsmen assembled each plane individually. There were no assembly lines for aircraft. Cars could be mass-produced. Aircraft could not. The technical requirements were too complex, the tolerances too precise, the materials too specialized. One German intelligence report from June 1940 concluded that Roosevelt's speech was a bluff intended to deter German aggression. The report stated American industry lacked the machine tools, the skilled workers, the engineering capacity, and the raw materials to produce more than 15,000 aircraft per year under optimal conditions. The analysts were certain America was not a military power. It was a nation of farmers and car makers who had never mobilized for industrial warfare. The United States had no modern army, no strategic air force, no experience with large-scale weapons production. German planners estimated it would take America at least 4 years to build the infrastructure needed for serious military production. By that time, Germany would control Europe and American intervention would be irrelevant. Hermann Göring, commander of the Luftwaffe, reinforced Hitler's confidence. Göring told the Führer that Americans could build excellent refrigerators and automobiles, but complex military aircraft required German engineering precision. The Americans lacked the industrial culture and technical sophistication for weapons manufacturing at scale. Hitler believed this belief would prove to be one of the most catastrophic intelligence failures in military history. But there was one man in America who thought Roosevelt's number might actually be possible. His name was Charles Sorensen, and he worked at Ford Motor Company as vice president of production. Sorensen was 60 years old in 1940. He was born in Denmark, came to America as a child, and spent his entire adult life at Ford. He had helped Henry Ford create the moving assembly line in 1913 at the Highland Park plant. That assembly line revolutionized manufacturing. Before Ford, cars were built like aircraft, one at a time, by teams of craftsmen. Ford's assembly line broke car production into sequential tasks, performed by workers stationed along a moving conveyor. Each worker did one job repeatedly as the chassis moved past. The result was mass production at unprecedented scale. By 1927, Ford had built 15 million Model T automobiles using assembly line methods. Sorensen understood something the German analysts did not. The principles of mass production could apply to anything, including aircraft. The Germans were right that American aircraft companies built planes like craftsmen, but they were wrong to assume that method was the only way. Sorensen had witnessed the transformation of automobile manufacturing from craft production to industrial scale. He believed the same transformation was possible for aircraft. The question was whether anyone would let him try. In January 1941, Sorensen traveled to San Diego to visit Consolidated Aircraft, the company that designed the B-24 Liberator bomber. Edsel Ford, Henry's son, and the company president went with him. They toured the Consolidated factory. Sorensen watched workers assembling B-24 bombers on the factory floor. There were no blueprints, just sketches and templates. Workers measured parts by hand, fit them together manually, drilled custom holes. filed edges until components matched. Each bomber was slightly different because every part was custom fitted. The factory could produce one B-24 per day, maybe. Consolidated management was proud of this output. They thought one bomber per day was excellent production. Sorensen thought it was insane. He saw what they could not see. The B-24 had 1,200,000 individual parts, but those parts could be standardized. They could be manufactured on precision machines. They could be assembled in sequence on a moving line. The technology already existed. Ford used it every day to build cars. A Ford V8 engine had over 200 precision, machined parts that fit together with tolerances measured in thousandths of an inch. The B-24 was larger and more complex, but not fundamentally different. It was an engineering challenge, not an impossibility. That night, Sorensen stayed up in his hotel room at the Coronado, thinking about what he had seen. He knew how to mass-produce complicated machines. A car engine had thousands of parts that had to fit precisely. OB-24 had more parts, but the principle was the same. Break the product into subassemblies, standardize every component, create tooling that produces identical parts, build the sub-assemblies in parallel, bring them together on a moving assembly line. Let the product move, not the workers. By 4:00 in the morning, Sorensen had sketched the entire plan on hotel stationery and the backs of placemats. He showed it to Edil Ford at breakfast. The plan called for a factory that could produce one B-24 bomber every single hour. Consolidated chief executive Reuben Fleet looked at Sorensen's sketches and laughed. He said it could not be done. Aircraft were not cars. The B-24 weighed 35 tons. It had a wingspan of 110 ft. Its engines alone weighed over 1,000 lb each. The idea of mass-producing bombers on an assembly line was absurd. Sorensen asked Fleet a simple question. If Ford agrees to build B-24s, will you provide the technical specifications and engineering support? Fleet said yes, assuming Ford would build subassemblies for final assembly at consolidated plant. Sorensen said no. Ford would build complete aircraft or nothing. Either Ford could run the entire production process using assembly line methods, or Ford was not interested. Fleet thought Sorensen was bluffing. He agreed to the terms. Certain Ford would fail. Sorensen went back to Michigan and convinced Henry Ford to build a factory specifically designed to mass-produce bombers. The plant would be unlike anything that had ever existed. The factory that became known as Willow Run. Construction began April 18, 1941. At a site 35 mi west of Detroit near Ypsilanti, Michigan. The architect was Albert Kahn, who had designed Ford's other factories, including the massive River Rouge complex. Sorensen gave Kahn the specifications. The building needed to be large enough to house an entire bomber assembly line under one roof. It needed conveyor systems, machine tools, storage for thousands of parts, and space for tens of thousands of workers. KHN designed an L-shaped structure covering 3.5 million square ft of floor space. It was the largest factory building in the world by a significant margin. No structure this large had ever been enclosed under a single roof. The assembly line would be 1 mile long with a 90 degrees turn halfway through. The plant would include its own power station, its own fire department, and its own hospital. Adjacent to the factory, Ford built Willow Run Airport with 6 runways so bombers could be test-flown immediately after leaving the assembly line. The airport included 3 hangars, the largest capable of housing 20 B-24s simultaneously. It also included a control tower, a cafe, and a hotel for test pilots. The total cost was $47 million, equivalent to over $800 million today. The construction itself was a massive undertaking. 300 men with saws, axes, and bulldozers cleared 100 acres of woodland. The site had been Camp Willow Run, a Ford-owned property used for youth camping programs. The land was adjacent to Willow Run Creek, which gave the facility its name, a steam-powered sawmill from Henry Ford's Greenfield Village Museum converted felled trees into 400,000 board feet of lumber used in temporary construction structures. The building materials included 44,000 tons of structural steel, more steel than was used to build the Empire State Building, over 1 million square ft of glass provided natural lighting throughout the facility. The concrete foundation required enough material to pave a highway from Detroit to Chicago. The roof alone covered 78 acres. Workers installed 500 m of electrical wiring and 93 mi of conveyor systems. The plant had its own water treatment facility and sewage system capable of serving a city of 50,000 people. Ford spent an additional $20 million on tooling and equipment. The company installed 7,500 machine tools, including massive presses capable of stamping entire wing sections. Some machines weighed over 100 tons and required special foundations. The scale of the operation was unprecedented. Everything about Willow Run was designed for one purpose: mass-producing heavy bombers at a rate no one believed was possible. German intelligence learned about Willow Run in mid-1941 through various sources, including trade publications and American newspapers, which openly reported on the massive factory construction. Their assessment remained unchanged. The factory might be large, but America still lacked the skilled workers, the precision tooling, and the organizational capability to mass-produce aircraft. The German Air Ministry estimated Willow Run would produce maybe 200 bombers per year at best, probably fewer. The factory was formally dedicated on October 22, 1941, in a ceremony attended by Major Jimmy Doolittle of the United States Army Air Forces, who would later lead the famous raid on Tokyo. Production began immediately. Parts manufacturing started that month. The first month, Willow Run produced 0 completed aircraft. In November, 0. In December, 0. In January 1942, 0. By February 1942, 9 months after construction began, Willow Run had produced exactly 0 B-24 bombers. The plant was running. Workers were present, machinery was operating, but no finished aircraft emerged. The problems were immense. American newspapers began calling the factory, "Will it run?" instead of Willow Run. The name stuck and became a source of embarrassment for Ford. Congressional investigators visited and wrote critical reports questioning whether Ford's automotive expertise would translate to aircraft production. Senator Harry Truman, chairman of the Senate Special Committee to investigate the National Defense Program, toured the facility in April 1942 and questioned whether Ford could actually make the transition from automobiles to aircraft. Truman's committee was investigating waste and inefficiency in defense production. Willow Run looked like a prime example. The plant had cost tens of millions of dollars, but had not produced a single combat-ready bomber. The problem was, Ford had never built aircraft before. The company had produced the Ford Trioder transport plane in the 1920s. But that was small-scale production of a much simpler aircraft. The B-24 was orders of magnitude more complex. The workers did not know how to work with aluminum. Automotive workers were accustomed to steel, which was harder and more forgiving of rough handling. Aluminum required different techniques, different tools, different training. The tolerances for aircraft parts were much tighter than automotive standards. Aircraft components had to fit precisely because any gap or misalignment affected aerodynamics and structural integrity. Cars could tolerate minor variations. Aircraft could not. The tooling designed for stamping car parts damaged the softer aluminum used in aircraft. Dies that worked perfectly for steel crushed aluminum. Sorensen had to redesign and rebuild thousands of tools. The cost was enormous. Millions of dollars in tooling was scrapped and replaced. Design changes from the military came constantly, requiring retooling that stopped production. 575 engineering changes were ordered in the first year alone. Every chain required modifications to tooling, jigs, fixtures, and assembly procedures. Some changes affected multiple subassemblies, creating cascading delays throughout the production system. And the B-24 was vastly more complex than a car. It had 1,200,000 parts compared to about 15,000 in an automobile. The logistics of managing that many components were staggering. Each part had to be manufactured, inspected, stored, tracked, and delivered to the assembly line at exactly the right time. A single missing part could stop production, but Sorensen kept pushing. He reorganized the workflow, retrained workers, redesigned tools, and broke the B-24 into 11 major assemblies and D-69 subassemblies. Each subassembly was built separately on its own production line, then delivered in sequence to the final assembly line. The center wing assembly became the heart of the production system. All prefabricated structures were manufactured to precise specifications, so they would snap into place without custom fitting. A multiple function machine completed 42 precision machining operations to 210,000 of an inch in 17 minutes. The transformation from craft production to mass production required retraining the entire workforce. Ford established an aircraft apprentice school at Willow Run that trained up to 8,000 students per week. Classes ran continuously. Workers learned riveting, sheet metal work, electrical systems, hydraulics, and quality control. The training was intense because aircraft work demanded higher standards than automotive production. A poor weld on a car frame was unacceptable. A poor weld on an aircraft could cause catastrophic failure in flight. Workers internalized this responsibility. They knew pilots' lives depended on their work. In September 1942, the first completed B-24 rolled out of Willow Run. It had taken 11 months from factory opening to first aircraft. The plane was christened the Spirit of Ypsilanti in a ceremony that drew local dignitaries and press. That bomber was not sent to combat. Neither were the next 55. They were used for training and transport because the quality was not good enough for combat operations. Army Air Force inspectors found defects, incomplete work, and deviations from specifications. Critics said the project was a disaster. A congressional committee report stated Ford had tried to build bombers like cars despite warnings from experienced aircraft manufacturers. The report was correct, but Sorensen did not stop. He used the rejected bombers as learning tools. Every defect was analyzed. Every problem became a training opportunity. Quality improved with each aircraft. In January 1943, Willow Run produced 31 bombers that met Army Air Force standards. In February 59, in March 75, in April 104, in May 130. The production numbers kept climbing month after month. Workers learned their jobs. Processes improved through constant refinement. Tools got better as engineers identified and fixed problems. By June 1943, Willow Run was producing 190 bombers per month. That was more than double Consolidated's original San Diego factory output, and the rate kept increasing. The breakthrough came when Ford successfully integrated all 11 major assemblies into a synchronized production system. Wings were built on parallel lines. Fusiliers moved through their own assembly process. Engines arrived from Pratt and Whitney and were prepared in a separate area. Gun turrets came from subcontractors and were tested before installation. Every component converged at the main assembly line in perfect sequence. In April 1944, Willow Run produced 453 B-4 bombers in 468 working hours. That was more than one bomber per hour. Exactly as Sorensen had promised 3 years earlier when Reuben Fleet had laughed at his hotel room sketches. The factory operated 24 hours per day in 3 shifts. A new bomber was completed every 63 minutes on average. The final assembly line moved continuously at a pace of about 100 ft per hour. Workers installed engines, mounted wings, fit gun turrets, connected hydraulic systems, and installed electronics. As the aircraft moved past their stations, each worker had a specific task and a specific time to complete it. The choreography was precise. At peak production, 42,000 people worked at Willow Run. The workforce was remarkably diverse for 1944 America. Most workers had never built anything more complex than a car. 65% were women, many of whom had never held industrial jobs before the war. African-American workers made up about 10% of the workforce despite facing discrimination in hiring and housing. The youngest workers were 18. The oldest were in their 60s. They came from farms, from retail jobs, from domestic service. Ford hired and trained them because the traditional pool of skilled industrial workers had been drafted into military service. Many workers traveled from Detroit on special buses because housing near the plant was limited. The trip took over an hour each way on roads that were often congested. Ford ran 165 private bus routes to bring workers to the plant. Public transit added 35 more routes. Simply moving 42,000 people to and from a factory in a rural area was a logistical challenge. The federal government built an entire residential community adjacent to Willow Run to house workers and their families. The community was called Bomber City and housed 14,000 people at its peak. It had temporary housing units, schools for workers, children, shops selling food and necessities, medical facilities staffed by doctors and nurses, and recreation areas including playgrounds and sports fields. Bomber City was essentially a small town that existed solely to support aircraft production. The federal government also built the Willow Run Expressway, one of America's first limited-access highways, to improve worker transportation from Detroit. The expressway opened in September 1942 and immediately eased congestion. Infrastructure that normally took decades to plan and build was completed in months because of wartime urgency. By the end of 1944, Willow Run had produced more aircraft than the entire nation of Japan built that year. Japan's total aircraft production in 1944 was approximately 28,000 planes of all types. Willow Run alone produced over 5,000 B-24s that year. And Willow Run was not the only factory transforming American aircraft production. Boeing in Seattle was building B-17 flying fortresses on assembly lines using methods similar to Willow Run. Boeing's Plant 2 employed 35,000 workers and produced 350 B-7s per month at peak production. The factory operated with the same relentless efficiency Ford brought to bomber production. Douglas Aircraft in Long Beach was mass producing C-47 transport planes that became the workhorse of Allied logistics. The C-47, military version of the DC-3 commercial airliner, was simpler than a bomber but still required precision manufacturing. Douglas built over 10,000 during the war. North American Aviation was building P-51 Mustang fighters at plants in California and Texas. The P-51 became arguably the best fighter aircraft of World War II, with performance that exceeded anything Germany or Japan produced. North American manufactured 15,000 Mustangs using progressive assembly methods. Consolidated owned factories in Fort Worth and San Diego were producing B-24s using modified assembly line methods they learned from Ford. Fort Worth eventually produced about 3,000 B-24s. Lockheed was building P-38 Lightning fighters, the distinctive twin-boom fighter that served in every theater of war. Lockheed produced 10,000 P-38s. Martin was building B-26 Marauders, medium bombers used extensively in Europe and the Pacific. Republic was building P-47 Thunderbolts, heavy fighters that proved highly effective in ground attack roles. Republic manufactured over 15,000 P-47s. Grumman was building F-6F Hellcats for the Navy, carrier-based fighters that dominated Pacific air combat. Grumman produced over 12,000 Hellcats. VA was building F-4U Corsair, another Navy fighter that became legendary for its performance. Every major aircraft manufacturer in America had converted to assembly line production. The transformation happened in less than 3 years. Small companies that had built dozens of aircraft per year in peacetime were suddenly producing hundreds per month. The automotive industry contributed significantly beyond Ford's Willow Run effort. General Motors produced over $10 billion worth of war materials, including aircraft engines, gun turrets, and complete aircraft. Chrysler built tanks, but also manufactured fuselage sections and other aircraft components. Nash Kelvinator, known for refrigerators, produced aircraft propellers and engines. The entire industrial base had been repurposed for war production. In 1941, American aircraft factories employed 159,000 workers and produced 19,330 aircraft. In 1942, employment reached 2 million workers and production hit 47,836 aircraft. That was more than double the previous year. In 1943, production reached 85,898 aircraft, nearly doubling again. In 1944, American factories produced 96,318 military aircraft. That was more than Roosevelt's original 50,000 per year target, nearly double. And the aircraft kept getting better. The B-17 evolved through multiple versions labeled A through G, each with improvements to defensive armament, engines, range, and bomb load. The final G model had 1350 caliber machine guns for defense, far more than early versions. The B-24 received constant upgrades to engines, defensive armament, and systems throughout its production run. Over a dozen B-24 variants were produced. The P-51 Mustang that entered service in 1943 was far superior to anything flying. In 1940, one with a range that allowed it to escort bombers all the way to Berlin and back, a capability that changed the strategic bombing campaign completely. Early war fighters had ranges of a few hundred miles. The P-51 could fly over 500 miles. This meant American bombers attacking deep into Germany finally had fighter protection for the entire mission. Before the P-51, bombers fought their way to targets unescorted and suffered terrible losses. With Mustang escorts, bomber losses dropped dramatically while German fighter losses increased. American factories were not just producing aircraft. They were producing better aircraft faster than anyone thought possible. The total production from 1940 to 1945 exceeded 300,000 military aircraft of all types. That number included trainers for pilot instruction, transports for moving cargo and personnel, fighters for air superiority and ground attack, bombers for strategic and tactical missions, and reconnaissance planes for intelligence gathering. The United States built more military aircraft during World War II than Britain. Germany, Japan, Italy, and the Soviet Union combined. Britain produced 130,000 aircraft during the war. Germany produced about 120,000. The Soviet Union produced over 150,000. An impressive achievement given that much of Soviet industry had been overrun by German invasion in 1941 and had to be rebuilt. Beyond the Ural Mountains, Japan produced 76,000 aircraft. Italy produced about 11,000 before switching sides in 1943. Total Axis production was approximately 207,000 aircraft. Total Allied production was over 600,000, with America contributing 300,000 of that total. The Germans noticed in early 1943. Luftwaffe intelligence received reports about American bomber formations over Germany. The numbers seemed wrong. Too many aircraft. American bombers were appearing in formations of 300, 400, even 500 aircraft at once. German fighter pilots reported encountering endless waves of B-17 and B-24 bombers escorted by swarms of P-47 and P-51 fighters. When German fighters shot down American bombers, more appeared the next day and the day after. The Americans seemed to have an unlimited supply of aircraft. Luftwaffe Commander Hermann Göring initially dismissed the reports as exaggeration. Fighter pilots overestimated enemy numbers during combat. That was normal, but the reports kept coming. By mid-1943, it was clear the Americans were deploying bomber forces on a scale Germany had never anticipated. The 8th Air Force, operating from England, was conducting daylight bombing raids with formations that sometimes exceeded 1,000 aircraft when fighters were included. The numbers were staggering. On a single mission in October 1943, the 8th Air Force dispatched 291 B-17 bombers to attack Schwein ball-bearing factories. Despite losing 60 bombers, the Americans returned 2 days later with another massive formation. This was industrial warfare on a scale Germany could not match. Every downed American bomber was replaced within a week. Every lost crew was replaced within a month. The replacement pipeline was so efficient that American bomber units maintained constant operational strength despite heavy losses. Albert Speer, Hitler's Minister of Armaments and War Production, reviewed German intelligence assessments of American industrial output. The numbers shocked him. American aircraft production in 1943 was over 3 times German production. American tank production was double German output. American ship building was producing 1 cargo ship every day. Speer realized Germany had fundamentally misunderstood American industrial capacity. In his post-war memoir, Inside the Third Reich, Speer reflected on how German leadership had dismissed accurate intelligence about American manufacturing capability. He wrote about meetings where Hitler refused to believe reports from German observers in America. The Führer insisted American production claims were propaganda and that German quality would overcome American quantity. Speer knew by 1943 that this belief was catastrophically wrong. Germany was producing excellent weapons, but not enough of them. America was producing good weapons in overwhelming numbers. In industrial warfare, overwhelming numbers mattered more than marginal quality advantages. Speer calculated that by 1944, American industry was producing twice the total war output of all Axis powers combined. Germany controlled the industrial resources of most of Europe, utilized millions of forced laborers, and ran factories 24 hours per day. Still, Germany could not match American production. German fighter pilot Adolf Galland commanded Luftwaffe fighter forces from November 1941 to January 1945. He witnessed the transformation of American air power firsthand. In 1942, Galland's fighters dominated the skies over Europe. The Luftwaffe had better aircraft, better training, and more experience than American pilots. German fighters shot down American bombers at rates that should have been unsustainable for the Americans, but the Americans kept coming. By mid-1943, the situation had reversed. American fighters appeared in overwhelming numbers, even when German pilots had tactical advantages. They were outnumbered 5-1, sometimes 10-1. Galland's pilots could shoot down American fighters, but more arrived the next day. The Americans did not seem to care about losses. They had so many aircraft they could afford attrition. One German pilot described it as trying to hold back an avalanche. You could stop individual bombers, kill individual Fighters, but the mass kept coming day after day, week after week, month after month. Galland reported to Hitler in late 1944 that German fighter forces were being overwhelmed not by superior tactics or better aircraft, but by sheer numbers. The Americans were producing more planes than Germany could destroy. Galland requested permission to withdraw fighters from the Eastern Front to defend German cities. Hitler refused. He still believed Germany could win through superior technology and fighting spirit. Galland knew better. The war had become a contest of industrial production and Germany was losing badly. At age 30 in 1942, Galland had become the youngest general in the German armed forces. By 1945, he was flying missions with an experimental jet fighter unit because conventional piston engine fighters could not compete with the mass of American aircraft flooding European skies. In December 1944, Germany launched the Ardennes offensive known as the Battle of the Bulge. The attack achieved initial surprise and made significant gains, but within 3 days, American air power appeared in overwhelming force. The weather had been overcast for the first days of the offensive, grounding Allied aircraft. This was deliberate. German planners had chosen this timing specifically because they knew clear weather would bring American air superiority. On December 23, the weather cleared. What happened next demonstrated the full power of American aircraft production. Hundreds of P-47 Thunderbolts and P-38 Lightning fighters attacked German columns. Formations of B-26 Marauder medium bombers struck German supply lines. Heavy bombers from the 8th Air Force diverted from strategic targets to hit German communications centers and rail yards. From December 23 to January 16, Allied air forces flew over 74,000 sorties and dropped 111,000 tons of bombs. They destroyed 11,378 German transport vehicles, 1,161 tanks and armored vehicles, 57 locomotives, 6,266 railroad cars, and 472 gun positions. German troops in the Ardennes had never seen such concentrated air power. The sky was filled with American aircraft. One German officer later described it as a vision of industrial hell. Everywhere you looked, American planes. They controlled the sky completely. German anti-aircraft guns shot down some aircraft, but more appeared immediately. The Germans had no effective counter. An Air Command and Staff College research paper later concluded that the Battle of the Bulge was the first time air power was used to halt a counter-offensive. The German advance rate of 20 km per day continued until December 23, slowed on December 24 and ceased December 25. The timing fit the air effort perfectly. The Ardennes offensive failed largely because American air power destroyed German supply columns and trapped German forces in a killing zone. And that air power existed because of factories like Willow Run. By January 1945, the Luftwaffe had ceased to exist as an effective fighting force. Germany still had fighters. They still had pilots, but fuel shortages, pilot attrition, and overwhelming numerical disadvantage meant German aircraft rarely challenged American air superiority. American bomber formations flew over Germany in daylight with minimal losses. Fighter escorts ranged across German skies, hunting for targets. German factories, rail lines, oil refineries, and transportation networks were systematically destroyed from the air. The strategic bombing campaign that devastated Germany was made possible by American aircraft production without the factories at Willow Run, Seattle, Long Beach, and dozens of other locations. The bombing campaign could not have been sustained. Each B-17 or B-24 that was shot down was replaced within days. Pilot losses were replaced by new crews trained in American flight schools. The Germans could not replace their losses at the same rate. When American industry finally stopped wartime aircraft production in August 1945, the total count stood at 300,000 military aircraft. That included 37,000 B-24s from multiple factories. Willow Run alone had built 8,685 of them, including 1,893 knockdown kits, shipped to other plants for assembly. The final B-24 left Willow Run on June 28, 1945. By that time, Charles Sorensen was gone from Ford. He had been forced out in a power struggle with Henry Ford on March 13, 1944, just as Willow Run reached peak production. Sorensen went to work for Willys Overland and never returned to Ford. He received no official recognition for Willow Run during the war. No medal, no commendation, no public acknowledgement. The success of Willow Run was attributed to American industrial strength and Ford Motor Company, but Sorensen's name rarely appeared in official accounts. William Cudson, who had worried in that Detroit office in May 1940 whether Roosevelt's targets were possible, became Commissioner of Industrial Production on the National Defense Advisory Commission on May 28, 1940. He spent the next 2 years coordinating industrial mobilization across the entire American economy. In January 1942, Cudson was commissioned as a lieutenant general in the United States Army, the only person in American history to enter the military directly at 3-star rank without any prior service. He worked with the War Department until 1945, organizing production of tanks, trucks, weapons, ammunition, and aircraft. After the war, he returned to private industry. Cudson later said that American victory in World War II was decided in factories, not on battlefields. The side that could produce more weapons, more ammunition, more aircraft, and more tanks would win. Everything else was tactics. Cudson believed American industry had not just defeated the Axis powers, it had buried them under an avalanche of production they could never match. His assessment was correct. The phrase arsenal of democracy, coined by Roosevelt, in a December 1940 radio address was not propaganda, it was literal truth. American factories produced 64% of all Allied military equipment used in World War II. By 1944, the United States was producing more war material than all other and nations in the world combined, including its own allies. Adolf Hitler lived to see the consequences of his miscalculation. By April 1945, Soviet armies were fighting in the streets of Berlin. American and British forces controlled Western Germany. German cities lay in ruins from strategic bombing. The Third Reich was collapsing. In his final days in the Fuhrer bunker, Hitler blamed his generals, blamed traitors, blamed everyone except himself and his advisors who had dismissed American industrial capacity as propaganda in 1940. Those advisors had told Hitler that Roosevelt's 50,000 aircraft per year was impossible. They had assured him American industry could never mobilize for total war. They had convinced him Germany would win before America could build enough weapons to matter. They were wrong about everything. The 50,000 aircraft per year that seemed impossible in May 1940 had been exceeded by 1944. American factories built 96,000 aircraft. That year alone, the total over 5 years reached 300,000. The Germans had called it propaganda. America built the planes anyway, and those planes destroyed the Third Reich from the air. Albert Speer survived the war and spent 20 years in Spandau prison as a convicted war criminal. In his memoir written in prison, Speer reflected on Germany's strategic mistakes. He wrote that the greatest error was underestimating American industrial power. German leaders had looked at America's small peacetime military and concluded America was weak. They had ignored America's massive industrial infrastructure, its engineering capability, its tradition of mass production innovation, and its capacity for rapid mobilization. Speer calculated that by 1944, a single American factory like Willow Run was producing more aircraft per month than entire German industrial regions. He wrote that Hitler's decision to declare war on America in December 1941 was the moment Germany lost World War II, not because of American military power. At that moment, America barely had an army, but because declaring war on America guaranteed that American industrial capacity would be turned fully toward destroying Germany, and once that industrial power was mobilized, Germany had no counter. Speer stated that if German intelligence had accurately assessed American industrial potential in 1940, Hitler might have made different strategic choices. But German analysts looked at American aircraft production in 1939, saw fewer than 3,000 planes, and assumed that represented America's maximum capability. They failed to understand that American industry had not yet tried to build aircraft at scale. The production in peacetime was constrained by limited military budgets and small orders, not by industrial capability. Once American industry applied mass production techniques developed for automobiles, shipbuilding, and machinery to aircraft. Manufacturing, the production numbers increased 32-fold in 4 years. No German planner had thought that was possible. The final count of American aircraft production during World War II stands at 300,000 military aircraft from 1940 to 1945. That number is difficult to comprehend because of its scale. 300,000 aircraft. If you laid them wingtip to wingtip, they would stretch from New York to Los Angeles and back twice. If you stacked them one on top of another, the stack would reach beyond the edge of space. The combined weight of all aircraft produced was over 6 billion pounds of aluminum, steel, rubber, and electronics. The production required 150 million board feet of lumber for crating and shipping. It consumed 2 billion rivets. It required enough electrical wiring to circle the Earth 40 times. The manufacturing employed over 2 million workers at peak production in 1943. Those workers operated in factories totaling over 100 million square ft of floor space. The factories used more electricity than the entire city of Detroit. They consumed raw materials shipped from every state and multiple countries. American industry built the supply chains, trained the workers, designed the tools, and solved the production problems in less than 4 years. From Roosevelt's speech in May 1940 to peak production in 194. 4 was exactly 4 years. In that time, American aircraft production increased from fewer than 3,000 planes per year to 96,318 planes in 1944 alone, a 32-fold increase. No other industrial mobilization in history matched that scale or speed. When historians analyze how the Allies won World War II, they focus on battles: D-Day, Midway, Stalingrad, the Battle of Britain. But those battles were won with equipment built in factories. The B-24 bombers that struck German industry were built at Willow Run. The P-51 Mustang fighters that escorted those bombers were built at North American aviation plants in California and Texas. The C-47 transport planes that dropped paratroopers at Normandy were built by Douglas in Long Beach. The Liberty ships that carried supplies across the Atlantic were built in shipyards using assembly line methods adapted from aircraft production. Every weapon, every vehicle, every bullet came from American factories. The soldiers, sailors, and airmen who used those weapons were brave. The generals who planned operations were skilled. But without the industrial base providing equipment in overwhelming quantities, tactics and courage would not have been enough. Germany had brave soldiers and skilled generals. Japan had highly trained pilots and experienced commanders. Both lost because they could not match Allied industrial production. American industry made Allied victory inevitable. Once the factories were running at full capacity, the Axis Powers were fighting a war they could not win. The outcome became a matter of time. The story of how America built 300,000 aircraft in 4 years is not just military history. It is a story about industrial capacity, engineering, innovation, organizational capability, and national mobilization. It is about Charles Sorensen staying up all night in a San Diego hotel room sketching an assembly line for bombers on placemats because he knew mass production could work. It is about 42,000 workers at Willow Run, most of them women, most with no prior manufacturing experience, building one bomber per hour through 3 shifts every day. It is about Albert K. Chen designing a factory larger than anything previously built to house a Million assembly line. It is about William Cudson coordinating industrial mobilization across thousands of factories in 48 states. It is about Roosevelt setting targets that seemed impossible and American industry meeting them. It is about German intelligence analysts looking at American production numbers in 1939 and concluding Roosevelt's speech was propaganda. Those analysts made a fatal error. They assumed American peacetime production represented maximum capacity. They did not understand that American industry had not yet tried to build aircraft at full scale. They did not anticipate assembly line mass production methods would work for aircraft. They could not imagine factories like Willow Run. And by the time German leaders realized their mistake, it was too late. The American industrial machine was fully mobilized and producing weapons faster than Germany could destroy them. That was the real lesson of World War II. Industrial capacity matters more than tactics. Production wins wars, and American industry outproduced the entire world combined. 300,000 aircraft in past 4 years from fewer than 3,000 per year in 1939 to over 96,000 in 1944. The Germans called it propaganda. America built them anyway. If you found this story compelling, please like this video. It helps us share more forgotten histories. Subscribe to stay connected with these untold stories and leave a comment telling us where you are watching from. Our community spans the globe, and every viewer helps keep these histories alive. Thank you for watching.